come to the final section, that is section 6 of Unit 6, the exponential distribution. It's also a continuous distribution. What do we look forward to? Going to state the PD of an exponential distribution, expected value of it, and the variance of exponential distribution. Good. The continuous random variable x is said to have exponential distribution with parameter lambda if its PDF is given by f of x set of lambda equal to lambda multiplying e, that's a natural log exponent minus lambda x, where x is greater than 0. If it is 0, that will be elsewhere. Remember that where x greater than 0 is called lambda greater than 0 is called the rate of the distribution. So here lambda is the rate of the distribution that we're talking about. Lambda is the rate. Now let's take an example. Jobs are brought to a corn milling machine at the rate of 5 jobs per hour. What is the probability that the job will be brought within 12 minutes? Remember, the job will be brought at the rate of 5 jobs per hour. And we said lambda is the rate. So let's look at the solution. So if S represents the time taken for a job to be brought, then since 5 jobs per hour means that lambda equal to 5, then you have the PDF of X to be given us. Just substitute the 5 into the distribution, okay? Yeah, because X, the lambda is the rate. But we know that 12 minutes, as I said, the thing is in hour. The job is given in hour, but we have to find the next 12 minutes. So what it means is that the 12 minutes should be converted to hours. And 12 minutes converted to hours will be equal to 1 over 5. That is 12 divided by 60. You know, 60 minutes make an hour. So 12 divided by 60 will give us 1 over 5 hours. And since this is a continuous distribution, remember we're told that the job will be given when? Within the next 12 minutes. That's x is less than 12 minutes. Or x is less than 1 over 5. So it means that from 0 to that last hour, or that last minute given, that will be, we're going to integrate from 0 to 1 over 5, and the function is 5e exponent minus 5x dx, and differentiating that and substituting in the value and working algebra very well will give us one minus e exponent negative 1. That will give a total of 0.6321. Yeah, when you take your time and work the algebra carefully, you're going to arrive at this. Substituting in the value one after the other, you're going to get it correctly. Don't be scared, right? Good. Let's make a progress. The mean and the variance of exponential distribution with parameter lambda. This is very simple. So the mean or the expected value is 1 over lambda, and the variance is 1 over lambda square. So if example 2, referring back to the first example, we have to find the expected value, expected time between jobs, and the variance of the job distribution with the first example. So remember that the lambda was 5. So expectation will be 1 over lambda, that is 1 over 5 hours, or 12 minutes. You know, 1 over 5 hours is the same as 12 minutes. The variance will be 1 over lambda squared, 1 over 5 squared, to give a 1 over 25. Converting this to minutes will be 2.4 minutes. 2.4 minutes. That is multiplying the hour by 60. Will give us minutes. Let's continue with example 3. Suppose that the time taken a university graduate to get employment is exponentially distributed with mean 2.4 years. Remember, this one was telling us the mean to be 2.4 years. He didn't say the rates. The mean is 2.4 years. Unlike the previous example that talked about the rate, here talk about the mean. And you know that the rate is lambda. And the mean in the previous question, or for the theorem, the mean is 1 over lambda. That's the expected value. So the mean is 1 over lambda. Now, let's continue the question. Find the probability that a fresh graduate will get employed not earlier than 3 years. Between 2 and 3 years. I hope it's clear. So that's the A part. So here we know that the mean is 2.4. And what will be the rate? Since the mean is 2.4, that is 1 over lambda is 2.4. Then lambda itself will be 1 over 2.4 by change of subject. You should be able to get that, right? So the PDF of x is given by f of x 1 over 2.4. And into the formula, we have 1 over 2.4 e exponent minus 1 over 2.4x. That's the distribution. Now, we have to find more than 3. Probability of x more than 3. More than 3. Of course, remember that in the question, more than 3 will mean that from 3 to infinity. So getting more than 3 will be 1 minus 0 to 2. Yes, 1 minus 0 to 2. If it is more than 4, it could have been 1 minus 0 to 3. I hope you get it. So that's what we have here as the function, integrating the function on the limit 0 to 2 and bringing the function here. And working out with the values correctly and putting in the appropriate value and doing the algebra carefully, we should be having 0.4346. Now you have to find between 2 and 3. That's very easier for us. So that's the lower limit is 2, the upper limit is 3. Working with the same values and putting in the function and doing our integration carefully and simplifying everything, we should have 0.1487. Thank you very much. And thank you for watching from Unit 1 to Unit 6. We have come to the end of this module. All the best also as you prepare to carry out your exam. Work out more examples. We'll contact your course tutor on this if you have any difficulty.